Cool. Okay. So we start our interface with the @interface designation like that. And if we want to create a new type, we just give it a name. What did we say the root class of almost every type we make is going to be inheriting? Or what did we say the root class of all of our types is going to be? Yes, Eric, thank you. NSObject. So NSObject provides, if you remember, under NSObject gives us the blueprint to initialize and allocate space to a new object that we're creating. All right. So we put our interface in the .header or the .h file. In here, I'm going to have my two properties, age and name. And then I'm going to have my instance method. Let's set that up right here. If my goal is to have a function or an instance method called popPitch that logs the person's age and name as part of a string, how can I get started with setting up the interface for that? If you remember, the interface doesn't actually have the code for how it works, but instead we just provide some simple information. What do we need to put? What do we put for a method in the interface? So Sunny, we're not going to go with a property. Yep, we need the return type. So on this line, start with the return type, which if this is a logging function, think of that like a print function. We're going to get void. And on this line, we're going to put the signature for our function. Ah, thanks, Eric. My void needs to be in parens. And then I can put the name for this function, name being popPitch. Now I'm going to get an exciting error. Interesting. We'll come back to that error. But just to be safe, what should I probably put at the end of this line? Amazing. Maybe I'll make a semicolon emoji. Levi asks, do all return types in the header file need to be in parens? Well, what happens if I do that? Space, interesting. Wow, how's that work? Excuse me. So these are both, don't know, thank you. These are both valid. Basically, the parens that we have around void here are to create a separation between the return type and the name of that instance method. But generally, the convention is to put in parens the return type because afterwards, and we're going to see this when we create our own custom init functions a little later, afterwards, the arguments coming into our popPitch are also going to look, and they're going to be in a similar pattern. So for consistency between return types and arguments, we'll use a, what's it called? Paren. Cool. Okay, thanks. All right, so this is the beginnings of our interface. We've got our .h file for our person. If we want to actually implement it, what letter, throw it in the Slack, what letter should be the file extension for my implementation? All right. Let's see, can I block Anthony's chat privileges? No. But yes, I'm seeing M. So .m, what is clunkily called the Objective-C file. I'll just call it the .m file because it's even shorter to say. That's where we're going to put the person's implementation. And it's going to mirror what we see in the interface. If you remember, the interface right here with the properties and with the instance methods and potentially class methods is kind of like the blueprint that we see with a protocol, except that this is actually communicating to other parts of the code that you can use this thing called a person. So a person is actually implemented. The interface tells you what you can use from that person. And when we get into how these properties work after our warm-up, we'll see, hey, makes sense. Gotta make sure I can let them see some stuff, but not see some other stuff. What, I know that's not a great way of putting it, but see some stuff, but not see some other stuff. What principle of object-oriented programming am I talking about? So it's not quite abstraction. Abstraction is more the boiling down of real world and complex functionalities and properties into our classes. But yeah, Jason and Liana, I'm seeing encapsulation. That's where we are actually taking we're taking and doing all the work, but we're only providing to people what they need to interface with our code. Another way of putting that is we're hiding the implementation to make coding with our types easier. So encapsulation is hiding everything that someone else using your code doesn't need to use. It's greatly simplifying, it's hiding the implementation. And that's exactly what this interface does. If I just have the interface and it tells me the properties and the instance methods, I don't need to know how it works. So if I just have this interface, I don't need to know how the implementation actually works. Cool. With that in mind, let's say we start making an implementation. Levi. Bye, Levi. Let's make an implementation for a person. Well, our implementation is going to need to actually implement all the stuff we said is going to go in a person in our interface. So in here, I can put a person, but I get this error. Why do I get this error? I gotta import. Rod, tell me more about importing.
I'm just gonna unmute. You've gotta import the file person that you made, or else you won't be able to access everything you needed in that class.
Thank you. Yeah, so when we go and create our implementation, we're gonna need to import the header for the type that we're trying to create. Let's see. So my errors go away because now it reads person.h, it reads that interface, and it can start implementing it. Are there any questions so far? Will we be making the properties for name and age too? Yes, you will. Thank you, Sunny. So I'm going to release the warm-up to you now. We've got our implementation. We've got our interface. I'll push this up as an initial commit to GitHub, and then let's take 16 minutes to do this as a warm-up. So we need our properties both in the interface and the implementation, and we need this function pop pitch, which is already in the interface, to actually do something with its implementation. Are there any questions before we move to this? Okay. So I'm gonna get init. I'm gonna get add all this stuff, get committed. Amazing. Has anyone ever done this before? With warm up setup. Now let's go make a repo. GitHub.com. David. Cool. That's nice. Objective-C classes. Continue. I'm going to throw into the Slack the link to this. Add my remote. Push to origin. You can all take that to get started. Sunny asks, any particular kind of property? It's amazing. Great question. What do you mean by that? Do you want to hop on the mic?
Sure. Excuse me. So there are different kinds of properties that we can create. And last time we created a copy property, which I believe makes a copy of the value. Is there any kind of specific property you want us to create for this class?
Yeah, that's great. So if you remember, when we create a property, by default, it's going to create get and set for it, looking at last week. Let's say the only thing you have to do with your properties is you have to rename the getter property. So if our property age is going to show up as age because it gets synthesized, then what we're going to need is to rename the getter. Should be years old when I try to access an instance of person. Otherwise, you can leave everything as is. Any other questions? Okay, I'm gonna stop my share for about 13 minutes. Start recording, great. Let's hop back into this object that we wanna create. So we're creating the interface and the implementation for a person. I got two properties, age and name. Let's start with this interface. So I'm gonna volunteer to walk me through how I can create new properties for this person. Perfect. Eric, I'm gonna hop you onto the mic. And also, I'm gonna ask you to start your video. I'd love to see you. Hi, Eric.
Oh,
How are you?
okay.
Great to see your face. Okay. So let's hop back into my Xcode. And I've got my interface. Can you start walking me through how I can create properties in the interface?
So you type in app property, parentheses copy, but I'm not sure why is it copy.
Okay. So we said last time that Slack, go away Slack. We said last time that copy is going to give us a new copy of this property because, very importantly, any object that we use in Objective-C can be referenced through a pointer. So if I want to assign some property to this object that's saved as some other variable, I'll want to sort of simulate what we have with a struct. And same to you, Olympia. So this isn't 100% necessary, but it's definitely going to be helpful. Keep going, Eric.
Next, I guess for name, you want an NS string.
And a string. Okay.
And then a pointer for name.
That.
Semicolon. And then you can just copy that whole row and just change name to age.
You could. So Michelle asks, why copy and not assign? We actually don't need either of them. By default, what this is going to do is, let's call this age. It's going to give us, do you remember what property builds in for us? So the keyword or the at property tag does something very specific and helpful for us. Anyone want to hop in? Does it pull data from the class? Okay, thanks, Eric. Eric's going away. Yeah, so Sam and Angela, I'm seeing some things. What property does is it sets up our accessors. Sets up accessors, which we're used to as read, write. We've seen that as get, set. By default property, we say synthesizes these things. Synthesizes a way to get the value of that property and synthesizes a way to set value of the property. The naming convention is our getter is just the name of the variable. Our setter is set name of variable. So when you use a property tag here, all of this is happening out of the box for you. If you want to change how that works, that's where we start to use those options and parens. So copy or assign do certain things that like affect how it's stored in memory. Copy will copy it. Assign actually does something that's a little like antiquated. We don't really need it. Those you can feel relatively safe with just using copy like a struct, like you would. But we can also do other things in these parens. So let's say name, we only want to be able to read name. We can call this a read-only property. And let's say we want to also have it be copy property. So we can add as many options as we want to this property thing because it's synthesizing all this stuff for us. We don't define how it copies stuff. We don't define that it's only got a getter. We provide these keywords. And now if I go to use name on an instance of person, I can do that, but I can't use set name because it's read-only. And I'll get a brand new fresh copy of that NS string if I assign it from a different variable. Similarly, we can do other janky stuff. So I also asked that the getter should be years old. And the way we do that is with another option. Is anyone able to find the option for changing the name of one of those synthesized accessors? Anyone at all? All right, let's take a look. So, got chat. I wanted age as an int. That's right, thank you. Let's say I only want to be able to set age. Nope, sorry. Let's say I want to rename the getter because right now, getter here is age and the setter is set age. I want to change this. Non-atomic. So Phoenix asks non-atomic. So that's also an attribute we can put in here. Non-atomic is going to do something for us when we're talking about threading. So non-atomic versus atomic. What these do is atomic makes sure that you are always dealing with a thread-safe copy of the property. So whenever I try to access it, because these are accessors, I will either need to wait for it to have mutated, or I will use it in exactly the state it is. I'm always guaranteed that that property can be accessed in the way I expect. Non-atomic is a little scarier, but also more helpful. We can access a property that's non-atomic at any time, in any state. So we could potentially run into issues if we're accessing the same property on multiple threads, if I am setting the value at one point and also trying to access it at that point. So these deal with thread safety. There's actually just another attribute called getter. So getter allows me to rename the synthesized accessor. I'm just going to say getter is years old. Let's see how that looks. Think of these parens as just a dictionary of options that you're providing to your interface. Each of my properties should work this way. This guy should be name. This guy should be called years old. Eric suggests tuple. Yes, that's a good idea. I say dictionary because the order that you put these in does not matter, actually. Whereas in tuple, they might matter. But appreciate it. Cool. So I'm renaming the synthesized getter for age here. Great. can I get a volunteer to help me implement this whole thing? I'm going to get rid of read-only because we do want both accessors, the getter and the setter, for this name property. Do-do-do. Do-do-do. Do-do-do-do-do. Da-da-da-da-da. Do-do-do-do. Why we want to keep copy? We don't necessarily. Don't need it. Do-do-do-do. Do-do-do-do-do. Do-do-do. Do-do-do-do. Do-do-do-do-do. Levi Davis, can you help me with my implementation here?
David L. Rifkin. I would love to do my best.
That's good.
Hello, you still there?
Yes, I'm excited.
Okay, great. Let's implement this pop pitch method.
Cool.
Why don't you open up some curly braces there?
Love to.
I'm gonna break them into 2 lines so that it's easier to read. And then why don't we just, because there's no return and all we're doing is logging something, let's just do nslog. And then let's do a string literal. So you got to start it with @ then parentheses. And let's say, hi, I'm a person doing my pop pitch. Dot, because it doesn't stop there. We're implying that it continues. And then let's put a semicolon at the end of the parenthesis there. That should work.
Well, let's take a look. What do we want pop pitch to actually print out? Yeah, we want it to print. We want this to print name, age.
Oh,
So Levi
yeah, let's do that.
and Swift. How would I get the values of those properties?
Well, you would use string interpolation, which would be the / and then parentheses.
And then how would I actually get the value for name if I put in the definition of a person?
You would have to use, I don't know, self.name or something like that.
Let's see if we can do that. Because if you remember from the last time we met, although Objective-C makes us use the message format for calling methods, with our accessors, we can use the same dot format for setting them. So how do you think you could get name and years old for this object?
Are we going to need to use a % sign?
I think so.
Which one?
Well, let's say my name is, and my age is, right here. Let's look back. Name is.
Is that the LU?
So it's going to be a little different. Name is an NS string. Phoenix says, let's use the formatter for an object, which is %@. So any object, any pointer, we can format in using %@. And here we're going to want to put something else because we have an int and not an object. Phoenix, do you want to hop in?
Sucker.
Levi, you can stay too.
I think you just use %D when you want to grab an int.
Now we need to provide 2 additional arguments, right? Name and the age. Name being that string, age being whatever the %D gives us. I guess that's an int. How are we going to get those in? Let's see if there's a certain word we're used to. Aha. There's still a cell. Still an age. This might be the most liberatory part of using Objective-C, because if we use properties using specific getters and setters, then we'll be able to access them in a very, very similar and familiar way to what we're used to with Swift. So it's really helpful here to be able to access name and age and then print them out.
Do our errors matter? Is that an important one right there?
This one,
Yeah.
our age, empty, that's because in here, I left this as a pointer, and really it's just the basic data type int. All right. Can we explain what it means to synthesize a property and why we don't need them? So when I say synthesizing a property, the compiler is actually what performs this quote unquote synthesis for us. By indicating we want a property, the whole nature and point of a property is that by default it is something that you read from at a certain point rather than having any value type. So a property is going to be reference unless otherwise specified. It's going to have a get and a set unless otherwise specified. And it's going to name those get and set in a particular way every single time unless you specify otherwise. So all of these attributes or options that you put in the properties interface, all of those specify different ways that you want the compiler to synthesize your property. Otherwise, it's just going to work out of the box for you. So there's a synthesize keyword, which you can use to change how it's synthesized as well. And we'll talk about that after we take a break when we talk about IVARs, or instance variables. But basically, because these properties are available on an instance, anyone can go and get them. But if we want private information, if I want name and age, then I want to do it slightly differently. I don't want to be, think of this as public versus private properties. These are all public properties. One is a constant. Sorry, one is retrieved using something like a computed property years old, but you can get and set both of them. If I set this to read only, and then set its getter is equal to years old, then what that would do for me is, this is kind of like a constant. I can only read an age, I can't set age. So my compiler won't try to synthesize this set age accessor for me. But for right now, let's make them both read write, except this one's a little funky when we read and write it. Cool. Do we think this will work? Do you want to try to use it? Where is years old coming from? Well, it's coming from my brain. You need to make a person first. Amazing. Cool. So years old is just for us to demonstrate that we can synthesize these properties in different ways. Out of the box, they're the way I just told you, with a getter and a setter that have this naming convention. but we can change that. We could also change our setter. And we could say our setter is set my age, something like that, because by default, the property would have called the setter set age. So there are a whole bunch of options we can set up in here. You could customize it, but the nice thing is by default, these properties give us get and set. They give us ways to access these properties, and they make them public on an instance of person. So Liana says we need to make a person first. All right, where can I make a person? Main. Yeah, let's go to main. All right. So I'm gonna start making a person. Someone jump in when you think I'm making a bad person. Person equal to person new, then person age. It's not working. Why isn't this working? Oh no. What's going on? I have to send a message. I think I have to do something before I even do that. Yeah, Rod, I think you're the import meister. So in order to use the interface for a person, I've got to import it. So I'm gonna start with an import statement. Oh no, I need this little indicator there. So I need this preprocessor import here. Say, let's bring up, I don't know, the header file, because that's got the interface. Cool. Is it gonna work now? Hope so. How do I call a function on person? Oh no, I can't method chain in Objective-C buddy. Thank you, I appreciate the friendship. So.
Hi, David. I think Liana asked a question. A lock in it, yeah.
Yeah, we're gonna go over that when we come back. It's something we saw last time, but now we'll do it in our own custom way. Thanks, Aram. Cool, how do I make this work? I wanna just call my persons. Well, it says I'm able to use this thing called pop pitch. The function called pop pitch. How do I do it? Send a message. Okay. Send a message. Cool. Kevin, I'm gonna hop you on. Can you walk me through how to send a message? Kevin, where are you? All right. Guess not. Let's see. Michelle, can you walk me through how to send a message?
No, I actually don't know.
Okay. So when we say send a message, we're saying basically the same thing as let's call an instance method. What's the way we do that in Objective-C?
No idea.
Sorry?
Don't know.
Okay. Let's bring back Kevin. Kevin, come on back. See if we can figure this out as a group.
What am I figuring out?
All right, so I've got a person. Now with that person, I want to send a message, which is pretty much the same thing as calling an instance method. Person's got one instance method. I can find it in its interface called pop_pitch. Like Angela said, the dash or the hyphen or the minus sign indicates an instance method. So I've got an instance of a person here. How can I call that pop_pitch method or send the message pop_pitch?
I'm not really sure on the syntax. Give me 1 second.
Okie dokie. I'll tell you, we called a message on line 27 as well. I'm sorry, sentiment.
Is it bracket person pop_pitch close bracket?
Yeah, let's do it. All right. Well, let's run our program and see what happens. I see Leon has a question. We'll come to that in just a sec. Interesting. So I can instantiate this person with properties, age and name, and it still works. That's great, but I want it to work in the right way, right? I created a new person. Really, all this new means is person is the combo of a lock plus a init. But all this new does for us is using the inherited NSObject functions, I am able to create a new instance. Those properties don't get assigned, so I could do something like person.set, yeah, there we go. Person set name. Let's name this person NSString. Yeah, let's do this on separate lines. Why is this not working? Okay. We're gonna have an NSString that is person's name, and that's gonna be a string that we init. All right. How do we get a value into this string? We can't just init it here because it's going to do the same thing. Because NSString just inherits from NSObject. Right? These two objects right now have all the same properties and functions because I'm just inheriting what I've got from NSObject. How can I create a new string with an actual like string literal in there that I can go and look at? So if we use the init, it's going to create an empty string, just like we saw. We can create a string literal. My name is Superman. Could do something like that. That's great. So when we talk about a literal, it's a shorthand for creating specific or instances of specific objects. So this is the shorthand or the literal way to create an NSString. Now I can set the person's name have it be person name. Great. Jason says we could have just done this in here. Also true. I need it. How can we set the person's age? Same way, put a number in there, but just the num. Okay, yes. So an int is one of our basic Objective-C types where it's not a pointer to an object, instead it's just some number. So set the age of Superman to be 34. What happened to years old? Interesting. Person, years old. So that's my getter. This one right here is my setter. So our setters synthesized the pattern we expected. And then this getter here synthesized from the attributes that we told the property to use. Namely, getter equals years old. So think of all that property stuff as just customizing how our properties work. Again, by default, you can have name and set name, age and set age, or I could, instead of age, have years old. So let's go ahead and run this. Aram, what do you think is going to happen when I run this?
Can I see the header file, please?
Sure. Let's look at the header file.
So we have a property called name, we have a getter, age, and a function called pop pitch. Okay, great, thank you. So I think it'll just print out, can you go up to the implementation of the pop pitch function?
Yeah.
Oh, great. Hi, I'm a person doing my pop pitch. My name is Superman, which is self.name, and my age is, what was it, 34? So that's what it should print out.
It should print out 34. All right. Well, let's take a look. Run this bad boy. Okay, what do you all think of this pop pitch?
Hi, I'm a person doing my pop pitch. Great.
Amazing. It's great. It's not good. Okay. Let's do an 8-minute break and you can leave feedback on this pop pitch. Hold on, Shell had a question. Does that mean years old doesn't make a difference or show up anywhere? Well, here where we are using person and using its interface, we're using years old here. We don't have age. So when we have an instance of a person, looking at its properties, looking at the accessors, so the getter and the setter, even though my property was called age in the interface, when I go to access it using a get, I can't just use age. I have to use years old because that's what was specified to be synthesized for the getter on this property. So when I have an actual instance of person, I can't use that age because we specified it's actually something else. It's going to be called years old to get the value of that property. Cool. All right, let's come back at 11:52. See you all then.
one question. Who is EN in the chat? Is that you, Ian?
All right. So let's hop back into our code, because I want to change up how we're doing things. So we got a person, we can set their name, we can set their age, that's great. But I don't want the user to be able to do that on the fly. Instead, I want them to have to create a new person with a name and with an age. Anyone got any ideas? This is another principle of OOP. We do want an initializer. And what principle OOP, object-oriented programming, are we applying here? Awesome. Angela, can I ask you to hop on mic and give us like 3 to 6 words about what polymorphism is?
The newer classes can behave differently than their the previous classes?
Yeah. We said there are 2 main ways they can behave differently. We'll start with an O. One of them we see every time we create a new view controller that inherits from UI view controller. There's a function there by default that does something with an inherited instance method. What's that keyword?
Override.
Awesome, thank you. So one that we're really used to is override. And the second is overload. That's where we have a bunch of functions named same thing. We overload a function by calling the same named function to do different things at a given time. Thank you, Angela. So Michelle suggests we create an initializer. I also think we should have an initializer. We've done this once before. An initializer of a person needs to be able to set up an object. And the good thing is all that computery, wizardry stuff is built into NSObject. So that init function creates new instances, creates new object instances. It does nothing else. Can't see what I'm typing. Does nothing else that's useful for us. And so we'll want to create our own custom init. We'll want to override the init that comes with NSObject so that when we init a person, we get the specific stuff that we're looking for. We actually did this last time. So let's go take a look at our code. Switch my screen share to just my whole desktop. Cool. So when we made a carnival barker, we created this init function. And what we were able to do is say, use the init that you get from our superclass, which so far, every time our superclass has been NSObject. Do that init and assign that to self. Now we'll want to do some additional stuff. But let's take this into our code. And of course, we're going to need to have it both in the interface and in the implementation so that we're able to actually use it in our code. So starting the interface, you might see inits done in one of two ways. Put this right up here. Init might return one of two types. Sometimes see ID type and the instance type. I know a lot of that is in quotes, but here is the thing. ID is a very special and specific way of creating a pointer. Think of this as like the most basic way to create a pointer to an object. All objects, so all pointers to a place in memory that are defined as objects, can be converted into ID. Think of this almost as an any in Swift. Whereas instance type is, well, it's a keyword. It's not itself a type, but instead it's kind of interpreting where it is. It's inside of a person. So if I return an instance type, I should expect that I see a person. So I should expect to see an object of the type I'm defining, or in the definition. How are we so far with that? Let me show you a quick example. Because ID is the generic type, I have an NS string called myString. I get the literal, I don't know, 16. Great. Let's say I have an NS number, my number. That's going to be an NS number that we initialize with an int. Check this out. Then Sunny will come to your question in a second. I've got these two things. ID working kind of like an any, and you can use it in the same places you need to, which is like, I don't know, if you're getting some random information off the internet and you need to translate it from a dictionary into another type, you could start with it as any. My ID, called my ID, could be my string, and then my ID could be my number. And it's not going to let us do this for a specific reason. What looks familiar here? What are some words that look familiar? Strong, pointer, cool. Implicit. All right. So this underscore underscore strong is actually interacting with automatic reference counting. That's familiar, right? ARC. ARC, this allows this. Why is that? Let's take a look again. Has to do with something we've seen since the second day we looked at Objective-C. Is it a weak variable when you first declare your variables? No, it's actually a little different. So an ID object, sorry, an ID reference points to an object, but look what color ID highlights as. It's not coming from Foundation. It's not something that is created by Objective-C. It's another one of our basic types. So let's get rid of that. ID is one of the basic types, like int. So I'm not creating a pointer to it, that I'm just creating one. So any functions like a basic object here. And what this means is that when you create something with a type of ID, or if you create an initializer with a type of ID, you are not going to get necessarily what you're looking for. Because it's like storing it in a variable. This is the basic object type. So all of this is to say, when you go to create an init, you should return an instance type rather than an ID. I think I heard you say ID creates a pointer for any type. So here we were creating a pointer, but no, it's not actually creating a pointer. It's creating an instance of ID, the basic type ID. Here we were trying to use it like an object, but it itself is not an object. So it wouldn't be interpolated using %at. We couldn't send messages to it. It's a basic type, just like an int. So avoid if possible. Instead, we're going to use instance type. Let's create an init function. Init. Cool. Well, this is our header file, so we're all done. Should we all go home? Levi is home. That's a really good point. Okay. So if it's in the interface, we're going to want to implement it. let's create an init. Custom init. Let's look at what we did last time. We'll set to self, so to that instance of this thing, whatever the initializers of the superclass is. So we inherit from NS object. Let's create an init. Great, sounds amazing. Self is equal to super init. And right now we can just return self. How do we feel about that? Don't we want to do more stuff? Let's say this custom init has to hide my age and name unless someone asks for my pop pitch. Weren't we? Levi, do you want to hop on the mic? Yes.
Hello, David. I thought we were trying to create an initializer that required name and age to be set so that we didn't have a situation like before where we had null and 0 as the values.
That's exactly correct.
Okay.
We do that with properties, right?
Yes.
These properties get set and we get them afterwards. Instead, this initializer. So initializer is going to have to take in some arguments.
That's what I was thinking.
Good, I'm glad we're on the same page. How do we add arguments? Let's go look at our header file. Or even, we could look at main, because here is a function, right? Returns an int, takes in 2 arguments. One is argc, one is argv. So I guess that's just the way we make a function. Cool. What would we want our 2 arguments in our init to be? Yeah, let's try it out. Name, string, age, int. Right, that's proper Swift, and Swift and Objective-C are the same thing. How do I type annotate a variable? Because I have to do that every time in Objective-C. Type does go first. Awesome. So let's see, string name, int age. Oh man, still not working. Change it in the header. We are in the header. I think it doesn't like the types I'm trying to use here. Gosh. All right, I want an int. So this int doesn't exist. It's upsetting. An NS string. All right. Hope that works. Interesting. NS string is not working for you, Liana. Why is that? Ruh-roh. Sunny, do you want to hop on and tell me what you're talking about?
don't know. I think we have to import foundation, but we were able to get NX objects outside of that, so I'm not sure.
Okay. What do other people think? What's the error? Great question. Expecting semicolon after method. Insert semicolon. Well, let's debug it a little together. First place we could look is here. All right, looks like our function signature is set up the right way. What about what's going on here? What do we think? How could we debug this from here? Can you only use types? Yes, I can. Well, an NS string is a type. It's just an object type. But what we need to look at is this main function is only taking basic types. And it's not an interface, it's an implementation. In our interface, we need to say how we're going to send a message to the object type person, which if you remember isn't in parens, right? When we send a message, it's in square brackets. We need to provide in the format it's used to that it should look for an NS string pointer. Think of these like the arguments we're defining. Unfortunately for us, it's not in parens like we're used to, but instead, in the square brackets for the init argument, we're going to put an NS string. And then for the age, we're going to put int. So when we set up the signature of a function, we don't put all the arguments in parens, but rather we're setting up the format that we're going to send a message to. This is the first function we've set up any arguments for. Wow, I don't like that at all. Yeah, that's fine. And it's also a little more opaque, right? Like init, well, this is why you so often see functions in Swift named like this, init with name, and then here I'm filling in the argument with an NS string, and then inside of the scope of my function, I'll use whatever argument was provided as the variable name, and then for the argument and age, I give an int, which is used as the int age inside of the function. Michelle, can you clarify your question? Why does age have an argument but not name?
I think you kind of answered it because you just put init. So I was a little confused.
Okay.
You're knitting it with the name and then the age, but yeah.
Cool. Yeah. So the convention that you so often see is for the arguments, you name exactly what you want in that space. which we see in Swift, but because because the function itself starts to get named with the first argument, right? This isn't just init, but I also have to say, here is the first argument to my function. Init with name, this argument that's an NS string name, and age. The format is yucky. When we send a message to an object, we aren't quite calling the function by name. And so this is part of why I would say, shout out to Swift for being the real MVP. I agree. This is part of why, like on a syntactic level, I wouldn't quite say sending a message and calling a function are the same thing, because inside of those square brackets, you're actually just providing values for argument names. It's a really yucky, disgusting thing, but it's okay. We'll get there. All right. Now, the whole point of this init with name and age, which I'm going to pop into our implementation, is the old one, and be the new. The whole point of all this was, hey, I actually don't want there to be getters and setters. I just want to initialize a person with a name and with an age, and then I want to be able to print that out when I ask for their pop pitch. So let's blow it up. Goodbye. Rid of you to make it private. Do this here as well. So now I only have 2 instance methods on a person. I don't have any properties. And that means that I'm going to see some broken code in here because I can't get my pop pitch. I can't set, I'm sorry, I can't do years old. And then pop pitch isn't working right now because it expects to read these properties. Computer, don't freeze. Cool. Quick reminder, this is really annoying, but you can declare instance methods before you implement them, just like we saw last time. I can declare this, and then later on in the code, do this. We don't need it right now. Go away. All right. Control reaches end of non-void function. How did I make private? I didn't make anything private just yet. But I got rid of the properties with the goal of making stuff private. Let's just debug this error real quick. What does this look similar to? Control reaches end of non-void function. Give me my error back. Come on. Go away. There we go. What does this error look like that we're familiar with Swift? Yep, saying we have to return something. Interesting. All right. What do we have to return? An instance type. Well, just like we've done with inheritance in view controllers and stuff like that, let's make sure that when we create an instance of this, we first call that same function that we inherit from the superclass. So the first line can still be a super init. Now we want to get that name and that age in there. How can we do that? Self, set name, set age. So that's an interesting idea. Do we want to set properties? We actually don't have properties anymore. It's a real shame. But instead, we use what we call instance variables. So let's take a look real quick at some documentation on instance variables. Oh, Treehouse, what do you have to say? Instance variables are basically pieces of information specific to an individual instance of a class. If we have a class car, an instance variable might be the number of miles on a car. In Objective-C, instance variables are commonly created with properties. It's an instance variable with some bonus features, such as setters and getters. So this is how regular properties work, but we actually want to do something a little more with this. In order to have it be private, instead of setting a property, in the definition, so in the interface, we say with these open squigglies, what variables are going to be available only within the scope of one instance of an object. So for example, they create a photo here where someone can read and write the NSString property photographer. So I can get photographer on an instance, or I can set photographer on an instance. Here, when we set up an instance variable, an IVAR, instead what we do is we set the value for that instance. We have to do that from somewhere private. So within the actual implementation, we have to set that. We can't call .setPhotographer. And that's typically what we'll do in the init, is we'll go say, hey, what private properties do I need? What IVARs do I need? Let's assign those. And then any subsequent functions for us, our pop pitch, can do us the solid of just looking at those private properties. Let's take a look at how we can do that. So we do it inside of squigglies. We're going to need age and name. Well, int is an age. Age is an int. And name is an NSString. How do we feel about that so far? Again, what we are hiding, what we're encapsulating is this age and name stuff. We don't want a user of our person object to be able to set them or get them. We only want them to be able to use them in this pop pitch function. So maybe I'm creating part of an app that uses a person. If I send you a person, an initialized instance of a person, then you can't do anything like age or namey. You can't set it, you can't get it. Instead, you can only call pop pitch. So I am hiding behavior, I am encapsulating it for you. All right. So that's all we have to do in our interface, is just say what IVARs are going to be available, what instance variables are going to be available. Cool. Here's a whole bunch of stuff. We don't really need this stuff. But if you see, you can actually write to them in the same way. This is overloading a variable. Probably should not do that. But anyway, let's make it work. So we've got our implementation here. Let's see, do we just do the same thing? Take my int, take my name, throw it in there. Oh man, instance variables already declared. Cool, so I don't need to declare them. Once I import the header, I don't need to take note of what IVARs I need. They're not like iPhones, they're IVARs. Cool. Now in here, I could say self dot, oh no, why can't I do that? I say name equal to name. I say age equal to age. Return self. Let's see what happens. Got some errors. Huh. I see some errors here. I named those things the same exact stuff that I had before. Right? I said, let's set name to be name. Let's set age to be age. It's not working. So I can't just call self for an IVAR. Can't just call self for an IVAR. Here's some ideas we have. Yes, Levi suggests doing exactly what they say to do. This is not recommended, but it does make it work. Just try name. Cool. Awesome. Interesting. Angela, why do you think that was, if you have any guess? Is it because it's an instance method? No, it's actually kind of the opposite. So this instance method is using the variables called name and age, but the whole point of an IVAR is a property defined in the scope of an instance, but it's not actually attached to the instance. So this is something a little new for us. This is a value that we can use only in the scope of a person, but it's not person's name. It's just some variable called name. It isn't self.name. It's just some variable that happens to exist in this scope called name. So a property synthesizing is what attaches it to self. Properties attach self. ivars don't. Ivars are kind of just floating around when we make an instance of a person. So name and age are not the person's name or age. They are just these things written to some variable. And Angela says, like a variable declared inside a func can only be used there. Exactly. So instance variables are variables that are scoped within an instance of a particular object, but they are not properties of that object. So if I, exactly. So it's just like if in Swift I did something like, let's run it. It's not going to work yet, Levi. Func A is this. Var B is 0. Can't use B out here. Can use B out here. Errors explain a lot too. Interesting. I'll put this down here. Eric, can you tell me what you mean when you say errors explain a lot too? Gotta break it to make it. Eric, hop on the mic and tell me what you want to do next. Yay. Come on up.
You may continue.
What? No, stay here. All right. I think a couple of you get where we're going, but basically I don't have these getters and setters anymore. So they're not going to work as messages I can send to an instance of a person. This doesn't work without a property. Add these here. Instead of initializing a person like that, let's create a person called Eric. I hope this works. A person. Before we go any farther, remember that to get an instance, we need to allocate space. So I could just do this here. I could later on do something like Eric it with name and age. At Eric. Eric, how old would you say you are?
25.
Cool. All right. Now, person is gone, but we have an Eric. Let's build this guy and see if it works. All right. Let me move all these screens. Guys, I have like 95 windows in Zoom. This stuff is not my favorite. Hang on just a sec. Oh no, it didn't work. Why not? Well, we can always go look at the interface and find out. It's still a net without the properties. Of course I can. Well, let's take a look at this. Think about this in Swift. this returns an instance type. So at line 51, this whole expression returns an instance type. That means that I'm not mutating Eric here, but rather I'm returning something and not storing that value in any variable. Could I do this? That sounds good. But yeah, Angela, I think I like where you're going with that. This is reassigning it. And then I can do it in one line, just like Michelle says. And this is where we get really excited about how beautiful it is to read Objective-C. Look at that. Wow. Beautiful. Let's run it. Rod, I agree. Oh no. It's still not working. Eric's pop pitch doesn't work. Yana, it also doesn't work for me. We are setting these instance variables, but I don't think we're using them in the right way. We might want to change our naming convention. Eric, you're not null to me, but let's take 7 minutes of looking around, seeing how IVARs work, and see if you can get this init with name to work. But it's for a very simple reason. Let's hop back in. So here I'm setting some values for my IVARs, but nullhead, thank you. But the thing about my IVARs is there's no way for me to distinguish between this argument that comes in and the IVAR I'm looking for. So if you look, when I have age highlighted, it's thinking I'm talking about the and age int value that I put in here. And because there's no self for IVARs, I can't distinguish what I'm talking about here. So this really nice init that we've gotten used to where self.name is name, self.age is age, in Swift, we can't do that. And did anyone come up with a solution? Sunny did the thing that I said not to. Name in parens. Give it a different name. Amazing. Michelle, I love it. Give it a different name. Right now it can't distinguish, and so we can't just do that self setup that we're used to. Instead, the practice that you'll often see with private variables or with IVARs as we have them here, in other language we call them private, is you'll put an underscore before the name to indicate that should only be used in this scope. So whenever you're using an IVAR, it should highlight in green like that, like a property. Why won't we want to use self? What we're asking it to do is, with that arrow, look inside of yourself for something called name. That's just not the proper way to use an IVAR. Instead, we want to just use it like any variable floating around. We'd rather not make our processor reference self there and say, fish around and see if you find this thing. It's not really the point of an IVAR. Instead, it's just something in this scope that I can use like a variable. So I've got name and age. And now those get set as sort of private variables with my init with name and age. And then I use them just like any variable in this scope for run it. Hi, Eric. It's your pop pitch. You exist now. That's amazing. All right. So that's where I want to stop off right now. What are some questions you have before we part ways? He does. Amazing. Can we make it so that is the only init you can use? Can you tell me more about what you mean, Levi?
Hi, David. We can still initialize, right, without setting the age and the name.
That's correct.
Can we make it so you can't do that? So the only way you can initialize it is by setting those two things at the time you initialize it.
Interesting. So you want to block the init function?
I don't. I just thought that was what we were doing, and now I feel unsatisfied that we haven't gotten there.
Yeah, so this is the unsatisfying part about inheritance, is that all of the init functionality is already declared in my superclass. So it's available to me at any point. So if I call init, it'll first try to see if there's an init defined in the person class. But if that doesn't exist, it's going to look at the superclass. So that's always going to be there with inheritance. I'm not really sure if there's a way to block inheritance in the way that you're talking about.
Okay.
Yeah. And then, just to go to Liana's point, we changed the names of those IVARs in the interface in order to use those different names in the implementation. Can I clarify new versus alloc init? Yes, new double equals alloc init. Alloc init is 2 steps, new is just syntactic sugar to do them in one. Here the init is the superclass's init because we haven't overridden the superclass's init. So if we look here, superclasses init is available. If we created a function here, that's just a regular init. And we said name equal to 2, age equal to 3. Get all the stuff from our superclass. And then return us, sorry. Then we've overridden the superclasses init when we call it, let's say, in here. And then I could, yes, I could use new with init, but not with init with name. So new is, think of it kind of like Codable. It's looking to do both alloc and init, specifically those functions by those names. So this is a simple example of overriding. And then this is an example of overloading. And those are our polymorphic functions. All right. Are there any more questions? Let's give it 10 seconds. Okay. All right, everyone. Thank you. I hope this lecture was okay for everyone. I'm really, really warm right now, so I got to find a new room. But yes, we will see you later this afternoon for stand-ups in your groups in Capstone. Thanks a lot. Have a great lunchtime.